Introduction to Permutations. Hello, everyone. Today's lecture is on the topic of permutations, which is an essential concept in mathematics. We're going to look into the basics of permutations, understand their importance, and explore various examples and applications. What is a permutation? A permutation is an arrangement of all the members of a set into a particular sequence or order. This concept is important in combinatorics, which is the branch of mathematics that deals with combinations of objects. Understanding permutations is crucial because it helps us solve problems related to probability, algorithms, and data organization. For example, when arranging books on a shelf or determining possible outcomes in a game, we are dealing with permutations. And let's take a look at Python code. Um, We will first start by importing the iter_tools module, which is useful for creating iterators, including permutations. And then we will define a list called elements containing 3 items, 1, 2, 3, and using the iter_tools permutations function, we can generate all possible permutations of the list. And this function returns an iterator, so we can convert it to a list for easier handling. Then you can print each permutation by iterating through the list of permutations. Why study permutations? Permutations are essential in various fields, such as mathematics, computer science, and statistics. They help us understand and solve complex problems involving arrangements and orderings. And in real-world applications, permutations are used in cryptography to encrypt information, in scheduling to determine possible task sequences, and even in games and puzzles like the Rubik's Cube. By studying permutation, you can gain valuable insights and tools to tackle these problems effectively. Basic definitions. Let's start with some basic definitions. The factorial, denoted as n factorial, is the product of all positive integers up to n. So for example, 5 factorial, written as 5 factorial, is 5 times 4 times 3 times 2 times 1, and which equals 120. A permutation of a set is simply an arrangement of the elements of that set. So for example, if we have a set containing the elements 1, 2, and 3, the permutations are the different ways we can arrange these 3 elements, such as 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on. And here is a Python example of calculating factorial. So you can import math module, which provides various mathematical functions along with factorial. Then you can use factorial function to calculate factorial. Notation. So the notation permutation of n choose R represents the number of permutations of n items taken r at a time. The formula for this is equal to n factorial divided by n minus r factorial. And this formula helps us calculate the number of possible permutations when we are selecting a subset of items from a larger set and arranging them in order. If we look at this Python code example, we first import the math modules, and then we can define permutation function that calculates the number of permutation given n and r value using the formula. So we have this formula here, math.factorial and integer division of math.factorial n minus r. So you can, once you have this, you can specify n and r value and call permutation. Example 1, permutations of a set. So you want to calculate the permutations of the set that contains A, B, and C. So this set has 3 elements. In order to find the number of permutations, you can calculate 3 factorial, which is 3 times 2 times 1, giving us 6. And the permutation of the set ABC are ABC, ACB, BAC, BCA, CAB, CBA. So there are 6 different ways to arrange these 3 elements. If you want to do this in code, you can import the itertools module and then define a list, and you can generate all possible permutations of this list using itertools permutations, and this returns iterator, and you want to convert the iterator to a list, then you can print each permutation by looking through the list of permutations. Example 2, permutations with repetition. So this is a different case where considering permutations with repetition. Say we have the set A, B. In order to calculate the number of permutations, we need to use formula for permutations of a multiset, which is n factorial divided by the factorial of the number of repetitions for each element. So in this case, we have 3 elements total with A repeating twice. So we calculate 3 factorial divided by 2 factorial times 1 factorial, which equals 6 divided by 2, giving us 3. So the permutations are AAB, ABA, BAA. If we are to do this in code, you can import the itertools and math modules, and we define a list of elements containing A, B. In order to calculate the number of unique permutations, we would want to first convert the list to a set to get the unique elements, and we count the number of repetitions for each unique element and store these counts in a list, and then we calculate the product of the factorial of these repetition counts. We then calculate the total number of unique permutations by dividing the factorial of the total number of elements by this product. And we can now generate all permutations of the list and convert it to a set to remove duplicates here. And then we can print the total number of unique permutations and each permutation. Permutations of subsets. So let's take a look at permutations of subset. We want to calculate the permutations of 3 items taken 2 at a time from the set 1, 2, 3. We then use permutation formula, which is n factorial divided by n minus r factorial. Here, n is 3 and r is 2. So we calculate 3 factorial divided by 3 minus 2 factorial, which is 6 divided by 1, giving us 6. So the permutation of 2 items from the set 1, 2, 3 are 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, and 3, 2. If you want to do this in code, you want to import the itertools module, and you want to define list of elements. And for this example, this list of elements contains 1, 2, 3. And you can generate permutations of 2 elements taken from this list using itertools permutations, but with a second argument of 2, which specifies the length of each permutation. And once you do this, it will return iterator, and you will convert this to list. Applications of permutations. So permutations have many real-world applications. In cryptography, permutations are used to scramble data for encryption, making it secure and difficult to decipher without the key. In scheduling, permutations help determine all possible ways to arrange tasks, therefore ensuring optimal resource allocation and efficiency. Additionally, permutations play an important role in solving puzzles and games. So for example, understanding permutations is key to solving the Rubik's Cube, where each twist and turn represents a permutation of the cube's smaller pieces. Here is a scheduling example. We will import the itertools module, and here is an example of a list of tasks containing task 1, task 2, task 3, and you can generate all possible schedules by finding all permutations of the task using itertools permutations and converting the iterator to a list. Permutations in probability. So permutations are also important in probability. They help us determine the likelihood of certain arrangements or orderings of events. So for example, if we want to know the probability of drawing a specific sequence of cards from a deck, we use permutations to calculate the number of possible sequences. This is important in statistical calculations and helps us make informed decisions based on the likelihood of different outcomes. So here is an example of drawing cards. We can import itertools module, and we define a list stack containing 5 card values, A, king, queen, jack, 10, and we can generate permutation of drawing 3 cards from this list using itertools permutation with a second argument of 3, which specifies the length of each permutation. Here is some more example. The question is to find the number of permutations of the letters in the word book, B-O-O-K. You want to remember to account for the repeated letters. To solve this, you want to calculate the factorial of the total number of letters divided by the factorial of the number of repetitions for each letter. So this is similar to example 2, permutation with repetition. So you want to calculate the number of unique permutations by converting the word to a set to get the unique letters, and then count the number of repetitions for each unique letter and store these counts in a list. And then you can calculate the product of the factorials of these repetition counts using math.prod, and then calculate the total number of unique permutations by dividing the factorial of the total number of letters by this product. Then you can generate all permutations of the word and then convert it to a set to remove duplicates. Here is another exercise. How many ways can you arrange 5 books on a shelf? You can think about how many different orders you can place the books in. So you can use the factorial of the number of books to find the solution. If you were to do this using Python, you can import math module, and we will define the number of books as 5, and you calculate the number of ways to arrange these books by finding the factorial of 5 using math factorial. For our final exercise, here is a question. In how many ways can 3 students be selected from a group of 5 and seated in a row? You can use the permutation formula to calculate the number of possible arrangement. So this will help reinforce your understanding of permutation of subset. So here is code. So you first define number of student n as 5 and the number of students to arrange r as 3. And you can use this formula n factorial divided by n minus r factorial to compute the number of ways to select and arrange 3 students out of 5. Conclusion. So permutations are arrangements of elements in a specific order. Factorials play a key role in calculating permutations, and understanding permutations is important for both theoretical and practical applications. So we looked at a number of examples and saw how permutations are used in different fields. This is it for the lecture. Thank you everyone for listening.